So the trapezoidal rule can be very effective depending on the circumstances, but there are some questions where it's just not very applicable. So if you had a function that looked like this and you were trying to approximate a trapezium, you've got some problems because your start point here is 0, your end point here is 0. So even if you were to then divide it up, and instead of going straight from A to C, you went from A to B and then B to C, you can see that once you put your shape in, there's quite a lot of error just here. Okay, so the question was then asked, well, how do we get a better approximation? Well, that's using a straight line that has a function of x with its highest power being 1. What if instead of just having the power of 1, we went to the power of 2, which means what if we used a parabola? What if we used an x squared function? You can see a parabola that goes through those 3 points gives you a much better approximation to the curve. Okay, now that's not always going to be the case. It does depend very much on what your circumstances are, and looking at the diagram is the best way that you have of trying to figure that out. You compare your parabola, compare your trapezium, and you can tell which one is going to be more accurate. But in a case like this, a parabola would give us a much nicer approximation for the area under that curve than the trapezium would. Alright, so what does this mean? Alright, well, what it means is that we have a new rule. It's not a trapezoidal rule anymore. This one is called Simpsons rule. So to approximate a definite integral using Simpsons rule, we need the midpoint, because a parabola that passes through 2 points, that's not enough information. There are many parabolas that could pass through those 2 points. We need a third point. So we use the midpoint, and that determines the 3 function values that we need. Okay, so one parabola, 3 function values. So if we have a look, you can see the little fs there. This is on your formula sheet. You don't need to memorize this. So this is Simpsons rule, and it tells you that it's Simpsons rule. So if we are approximating a function from a to b, then our rule is now b minus a over 6 outside of f of a plus 4 times f of a plus b over 2 plus f of b. Okay, sorry, but that should look like that. Anyway, so if we are asked to approximate this function, so we've got the square root of 4 minus x squared from 0 to 2 using Simpsons rules with 3 function values. So 3 function values means we have 1 parabola. All right, just like trapezoidal rule, draw yourself a table. All right, so what are the 3 values of x? Well, we're going from 0 to 2, which means the midpoint would be at 1. And what is f of x? So f of 0, you put 0 in there, 4 minus 0 squared, and then the square root, you get 2. You put x is equal to 1, 4 minus 1 squared, and take the square root, you get root 3. And then if you put in 2, 4 minus 2 squared, you end up with 0. So when you're substituting that in, we say that this is approximately equal to, so b minus a, b is 2, a is 0. They're your endpoints, yeah? And it is outside of, now f of a is just your first function value, which we said is 2, and then it is 4 times the function value at the middle, so it's 4 times root 3, and then it's the end one. Now all that goes into your calculator, which very conveniently gives you the approximation of 2.976 to 3 decimal places. So that is Simpsons rule using 3 function values. Alright. In the real world, this is generally applied to things like blocks of land where we don't know what the function is, because later on in this topic we will learn how to work that out exactly without having to approximate it. But out in the real world, there are things like rivers that don't follow nice little mathematical paths. So, HSC questions often look something like this. This is from 2009, and it says the diagram shows a block of land and its dimensions in meters. So what they've got is this block of land, and we've got 3 straight sides, and then there's this river. All right. So the measurements are taken perpendicular, so they walk along, and then they take a measurement, and they walk along, and they take another measurement. and the interval is 50 meters. So this is 0, 50, 100, 150, etc. They want us to use Simpsons rule. So instantly, you know what that is. It's on your formula sheet, Simpsons rule. And they want 6 sub-intervals. So this relates back to the trapezoidal rule, where they can tell you how many trapeziums or how many function values. We want 6 sub-intervals. So you can see they've cut that up into 6 pieces here. Okay, so that's your 1, 2, 3, 4, 5, 6. If we have 6 subintervals, how many function values do we have? We have to measure at the beginning, and then we have to measure at the end of each of those 6 subintervals. We have 7 function values. Okay, and they're just those 7 measurements across there. So they haven't given us a function, they haven't given us what the f of x is, but they've told us what its value is at. So this is f of a. Okay, this is your midpoint, this is b. Then we start again. This is a, this is your midpoint, this is b. And then we start again. This is a, your midpoint, and b. Okay, so we're dividing it up into 3 parabolas, which makes sense. If you have a look at that, well, what we have here is this concave down parabola, and then here we move to a concave up parabola, and then here we move to a concave down parabola. So it would make sense to do it like that. If you just did one parabola for this, it wouldn't be as accurate as it is by splitting it up and fitting it better. Okay? Again, table of values. What are your x's going to be? Well, in this case, we don't have a starting point. X is equal to something and then an end point. But we know it goes up by 50 every time. Yeah? So we just call this 0, 50, 1, 152. And our f of x's, well, they're this height here. So 210, 220, 200, etc. So, table. You can see it there. That's pretty easy to draw up from that picture. The thing that we need to realise, though, is where does each of the parabolas that we're using start and end? Okay, so when we do the first one, we're taking into account these 3 function values, all right? We start at 0, we end at 100. But then, when you do your next parabola, well, it starts at 200, and it goes to 210. And then your last parabola starts at 210, and it goes to 240. So you need to think very carefully about where your parabolas are. Okay? And then you just apply this 3 times. So it's up to you to figure out how many times you need to apply it when they give you the information like this. That's the really important bit. Alright? So, we're being asked to work out the parabola, the first one, where we're going from 0 to 100. We don't know what the f of x is, but we know from our Simpsons rule that it is going to be b minus a, so 100 minus 0 all over 6, outside of, what's the first measurement? 210 plus 4 times the second measurement, so 220, plus the last measurement, 200. Okay? Then we have our second application, which is going from the point 100 to 200. And it follows a very similar pattern, doesn't it? 200 minus 100. Hey, that's going to give you 100 as well, just like the one above it. And that is going to be outside of 200 plus 4 times 190 plus 210. You're just going first, the middle, the last, first, the middle, the last. You've got this pattern happening. We've also got the third one, which is going from 200 to 300, which we can approximate using 300 minus 200. Hey, that ends up being 100 as well. Funny that. Outside of, so this one starts at the first, 210, 4 times the middle, oops, and the last. Okay, so all of those go into your wonderful calculator. and you put it all into your calculator and you add it up and you get 64,500 square meters. Okay, now you can use that formula exactly as it is and just repeatedly, just like we said with the the trapezoidal rule, or there is a general form as well. Again. Okay, so this is your general rule. You are welcome to learn it if you like. You will see there's a h over 3. So the h is the height of each subinterval. So if you are going back here, the h from here to here is 50. From here to here is 50. So h is the 50. Okay, so instead of using the endpoints, you're using the height of each part. Alright, so it's h over 3. Y0 and y to the n, they're your first and your last measurements because you only use them once. You use the first one on the first parabola, you use the second one on the last one on the last parabola. Okay, and then on the odd numbers, so they're the midpoints, we get 4 of those because that comes from that formula that we use. And then we have 2 times the even ones. Now it's up to you if you want to learn that. I've never memorized it. I just apply it repeatedly as I've shown you in the example. But the option is there for you to use that and memorize that if you want. So that's what you need to be able to do exercise 3.2. I would like you to again have a go at the odd questions. Good luck. See you in class.